For this next page, remember that you do not need to do problems 23, 25, 24, 27, or 29. For problem 20, we should also see if we can take 0 and simply substitute it in. So if we have the limit as x approaches 0 of 3 times 0 divided by the cosine of 0, the cosine of 0 is actually 1. So we don't have anything that's undefined. We just have 3 times 0 divided by 1, which is just 0. For number 21, we have the limit as x approaches 0 of 3 times x sine x. We know the theorem that the limit as x approaches 0 of x over sine x equals 1. So we want to first take the 3 and pull it out in front using properties of limits. Now we know that this portion equals 1, so 3 times 1 equals 3. For 22, we need to break up the function first and then try to use our theorems to help us solve it. So first, we have the limit as x approaches 0 of sine 3x times 1 over sine of 8x. So now if we had a 3x underneath sine 3x, we know the limit of that would go to 1 as x approaches 0. And if we had an 8x over sine 8x, we know that the limit of that would approach 1. So what I'm going to do is multiply the first term by 3x over 3x and the second term by 8x over 8x. This will give me the limit as x approaches 0, and I can take this 3x and slide them right underneath sine 3x, and I can take the 8x and put them on top, and then I can take my extra 3x and put them over the extra 8x as a separate term. So let's write him first, 3x over 8x times the limit as x approaches 0 of sine 3x over 3x times the limit as x approaches 0 of 8x over sine 8x. So now for our first term, we can cancel out the x's, and we'll just get the number 3/8. Here we have our theorem, so that equals 1, and the limit of 8x over sine ax will also equal 1. So our final answer is 3/8. For 26, we also want to break up our fractions so we can have some theorems going on. So we have the limit as x approaches 0 of x times sine x. And 1 minus cosine squared x, there's no theorem that has that in there. So we're going to change him to a sine squared x. Now we can cancel a sine x with the sine squared x and just leave it as a sine x. And we can rewrite this as the limit as x approaches 0 of x times the limit as x approaches 0 of x over sine x. So now we have our theorem, and the limit as x approaches 0 of x is 0. So we have 0 times 1, which equals 0. For number 28, we want to first expand 3 plus h squared. So we have the limit as h approaches 0 of 9 plus 6h plus h squared minus 9 all over h. Our two 9's will cancel. So we have the limit as h approaches 0 of 6h plus h squared divided by h. We can take the h's and cancel 1. So we have the limit as h approaches 0 of 6 plus h, and after we substitute 0 in for h, we get that our limit is 6. For number 30, we have the limit as h approaches 0 of 1 over x plus h minus 1 over x all over h. This is a complex fraction that we need to simplify first. And to simplify a complex fraction, we multiply by the common denominators. So we have x plus h, and we have an x, so we want to multiply each term by x times x plus h. So when we multiply, our x plus h's will cancel. So we'll have the limit as h approaches 0 of x minus, here our x's will cancel, and our negative 1 will distribute. So we have negative x minus h. And then the bottom we have xh times x plus h. In the numerator, our x's will cancel. So we have a negative h over xh times x plus h. And then our h's will cancel. So we're left with the limit as h approaches 0 of negative 1 over x times x plus h. So now we can take 0 and plug them in for h. So we have negative 1 over x times x plus 0, which is just negative 1 over x squared as our final answer. In problem set 2, number 1, we have the limit as x approaches 2 of x squared minus 4 over x squared plus 2. If we take 2 and substitute them in for x, we have, reset. We have 2 squared minus 4 over 2 squared plus 4, which is 0 over 8, which equals 0. We can have 0 in the numerator, but not the denominator. For number 2, we have the limit as x approaches infinity of 4 minus x squared over x squared minus 1. So if we divide each term by x squared, we end up with the limit as x approaches infinity of 0 minus 1 over 1 minus 0. So our answer will be negative 1. For number 3, we have the limit as x approaches 3 of x minus 3 over x squared minus 2x minus 3. So we want to factor the denominator. So we'll have x minus 3 times x plus 1. Our x minus 3's will cancel. So we'll have 1 over 3 plus 1, which equals 1/4. For number 4, the limit as x approaches 0 of x over x. We can't take 0 and plug it in. However, x over x simplifies to 1. So the limit as x approaches 0 of 1 equals 1. For number 5, we want to use the sum of cubes to factor the numerator. So we have the limit as x approaches 2 of x minus 2 times x squared plus 2x plus 4 all over x plus 2, x minus 2. So our x minus 2's will cancel out, and we can take 2 now and substitute him in. So we have 2 squared plus 2 times 2 plus 4 all over 2 plus 2. And that will equal 3. For number 6, again, we have a limit as x approaches infinity, so we want to divide each term again by x squared. So we have the limit as x approaches infinity of 4 over x squared minus x squared over x squared over 4x squared over x squared minus x over x squared minus 2 over x squared. That will be the limit as x approaches infinity of 0 minus 1 over 4 minus 0 minus 0. So negative 1/4 would be our final answer. For number 7, we're finding the limit as x approaches negative infinity. So we need to be extra careful with our final answer. So we're still going to divide everybody by the largest exponent in the denominator, which is x squared. So we have the limit as x approaches negative infinity of 5x cubed over x squared plus 27 over x squared all over 20x squared over x squared plus 10x over x squared plus 9 over x squared. So this will simplify to the limit as x approaches negative infinity of 5x over 20. So now, if we think about what happens if we plug in very large negative numbers, this will increase without bounds, but towards negative infinity. So our final answer is negative infinity. For number 8, we have the limit as x approaches positive infinity of 3x squared plus 27 over x cubed minus 27. So again, we want to divide everyone by x cubed. So we have the limit as x approaches infinity of 3x squared over x cubed plus 27 over x cubed all over x cubed over x cubed minus 27 over x cubed. So we have the limit as x approaches infinity of 3 over x plus 27 over x cubed over 1 minus 27 over x cubed. So this will be 0 over 1, which equals 0. For 29, we have the limit as x approaches infinity of 2 to the negative x over 2 to the x. And we want to simplify by subtracting our exponents. So an x minus a negative x is a 2x. So we have 1 over 2 to the 2x. Now, if we keep plugging in bigger and bigger numbers for x, the bottom will get extremely big and the top will stay 1, so this will tend to 0.